Hello, Professor. This is John Perez from the EFDT team, and with this video, I want to go over the Bollinger algorithm that our team has been developing. Sadie was the first one to work on this, then Yair made improvements, and now it was passed on to me. Um, my main purpose was to figure out a way to find the squeeze accurately, the way that Gordon does with his own eyes. I figured out a pretty simple way to do it in the most accurate way possible, and also leaving parameters that can be changed around to improve it, to give it different attributes so it's more accurate or less accurate depending on what we want. So I'm going to describe briefly the algorithm. It's based on bandwidth, which is basically the upper minus the lower divided by the base and then times 100. This gives us a ratio of the bandwidth, so it would be upper minus lower divided by the base, and that gives us the so-called bandwidth. So what I'm doing is I'm using a queue, first in first out, to store the last 5 bandwidths available. So I store the first one here, then on the next one it pushes, the next one pushes and pushes until we have 5, and then it keeps pushing out down this tail and into this head, the bandwidths. I call these first two the heads, and these last three the tails, and the difference between the head and the tail is what's gonna identify the squeeze, the way like an eye would do it, but algorithmically. So here I describe what I do. So this would be bandwidth 0, so this is like the most recent 2, and then these are the older ones. These are the head. So what I do is I save the average of the head. I do bandwidth 0 plus 1 divided by 2, and then 2, 3, and 4 divided by 3, and I get, these are not ratios, my bad, these are averages. And then I grab these averages, the head one first over the average of the tail, and I check them against a value, a parameter. I call this parameter, I believe it's the squeeze ratio, and I used, I believe, 1.2 as the expansion ratio. So this means when the head over the tail is less than 0.6, for example, when these two are like, the average of these two is 0.6 of the average of these three, it's an indication of a squeeze. So we can see this on the code now. This is the actual expert advisor I've been using to test, and this is the signal itself. So on the expert advisor, I created this is the squeeze ratio, and this is the expansion ratio. So I have it at 0.7 actually right now, and at 1.2. And these are parameters that you can change in the MetaTrader itself over here. So you can change them and test them as we go. The code itself for the signals over here, and it's exactly as the algorithm describes. So I have a buffer here for my bandwidths. Here's my queue. I call it the queue window. It's almost like a window that's going along, and I save the bandwidth. Then I keep saving them until the count is greater than 5, and then I start dequeuing them to make sure it stays at 5. Each time a long condition is checked, I calculate the tail, the head, and the ratio of the head and the tail, and then I check it against the squeeze ratio. If the squeeze ratio satisfies the whatever ratio I put, then I set a flag to true, signaling, hey, the squeeze starts right here. Then once it's set to true, then the only thing we have to wait for is the expansion. I have an expansion ratio here, and that the start of the expansion along with a break of the line would be the so-called confirmation that Gordon describes. So basically this expansion and the actual line break, which I'm checking here, this is just a momentary line break, as we're going to change all the line breaks into a separate signal. But I'm using this for now, which stems out from the algorithm that Yair was developing at the beginning. yeah, so once the confirmation is done and it's inside the squeeze, it satisfies the condition and it goes here, it resets the flags and it returns 100. This is, so obviously right here it's just checking for the squeeze, and on the short condition is checking for the expansion. I did this with the purpose of showing that the algorithm actually works. So to be able to visualize it, for example, here as you can see, squeeze is happening. Here an expansion is happening. So this is the long condition. The long condition. This is the short condition. There's another squeeze. So it's saying here squeeze. So it's here. This is not how the algorithm actually works. It's just for testing purposes. To show how it actually works, I'm gonna change here the if statements. So the actual condition we want to check for is an expansion, which means there's a squeeze, there's an expansion, and there is a line break. Same in the bottom. For the short condition, we have to check there's an expansion and there's a line break, obviously in the other direction, and I'm taking that into account. So we can compile this, compile here, run it again. And if we check, obviously it's not perfect. It still has needs to be paired up with the other ones. Let's say for example here, the line is broken, so it entered and is after the squeeze. Check another one. Right here there was an expansion, and we can change the ratios to get bigger expansions or more aggressive squeezes. I only check for those, but in general it checks for the break after the squeeze, and it does the appropriate buy or sell, and it's only doing 1 pip for now. Things to note, Gordon did mention that as the squeeze extended, the longer the squeeze was, the stronger was the signal. Right now I have a static signal at 100, but I'm working on a length squeeze multiplier that is added depending on how long the squeeze takes, and then it's returned, so that there's a representation of a higher probability and a lower probability, so that when I separate this from the actual line breaks and we have all the line breaks in one module and all the probabilities in another module, this is just a range that is put out along with RSI and MACD, and then the confirmation just adds on to that, and we get a comprehensive signal. So yeah, that's what we got so far in terms of Bollinger, and we're still working on it. Right now, our purpose is separating these confirmation signals, integrating with RSI, and starting doing the confirmation signals along with the other lines, the breakage lines that we have to make. Thank you.